Okay, good morning, everyone. This is Tom Burnham with MnDOT Research. And today's webinar is going to be on the Guide for Concrete Pavement Distress Assessments and Solution. This is a very large document that I had the pleasure of being involved in the development of. In fact, we have other people here that have been involved in it. It's quite a multi-year effort. It's very huge. You can picture before this we had perhaps the LTPP distress manual to kind of identify stresses. This much goes into much greater detail. We're talking about the causes and solutions to how to fix these distresses. It's also kind of unique that it now is starting to address overlays, which we're starting to live with. So today's presenter is Dale Harrington. Had the privilege of knowing him and working with him for many years now, probably 15 years, and he's very instrumental. He's one of the founding directors of the CP Tech Center at Iowa State University, and currently he's the president of HCE Services and has over 46 years of PE experience. Very experienced, and it's been around a long time, involved with concrete pavements.
Sounds good. Let's get going. Bob, you want to switch to the next slide? Okay. About 3 years ago, I went into the director of the National Center at Iowa State University, which is who I work for, and said that I have gotten so many calls from so many state engineers and city engineers and county engineers that they cannot understand what causes some of the pavement distresses, and they have no document to go to find out what the issues are. So, to make a long story short, we went to the Federal Highway Administration, and they were good enough to fund us to do a distress manual, what we refer to as a coin word distress manual. It's actually the Concrete Pavement Distress Assessments and Solutions Manual. And the whole idea was to develop the guide so inspectors, design engineers, whatever engineer, doesn't make any difference, or technician, could go out in the field or on their phone or computer and look up a particular pavement distress that they see in concrete pavements and determine relatively quickly what some of those distresses were. Next slide. So we wanted to allow people to identify a particular problem in the concrete pavement. What is that? Understand what that distress causes were, prevent the future distresses by knowing what to do and how to prevent it, and then what rehabilitation repair methodologies were available to them. Next slide. The document was started in just about 3 years ago, not quite, but 2 years and 7 months ago. And it was finished in October of 2018. As was stated earlier, it's about 470 pages. It has an EPUB version. By that I mean you can put it on your, with an app, you can put it on your phone. It has 8 authors, very good authors. Gary Fick, Mark Snyder, Tom Kackler, Mike Ayers, Doug Schwartz, Kurt Smith, and Tom Van Dam. So that was quite a good group. And then they put up with me as one of the authors and the project manager. We had 16 technical advisory committee members. On my presentation that I was going to give to you today, I did have a listing of those gentlemen on that, but unfortunately you're just going to have to put up with the fact that we had 16 because I can't name them. There is one that's on, or two on, that's from Minnesota, and Tom Perm that you heard earlier this morning, and then Matt Zeller from the Concrete Pavement Association of Minnesota. And we appreciate all 16 individuals' efforts because it's quite an effort. Next slide, please. The slide that you see in front of you is basically the 19 chapters. And about 70% of the manual is based off of full depth pavement, from surface defects down to CRCP concrete pavements. That's the first division. The second division is made up of concrete overlays, which is about 25% of the entire booklet. And then the last division, which the committee felt was pretty important, that we wanted a laboratory and field testing division, which allows us to, an individual, to go into that section of the manual and understand some of the testing and some of the nuances of that testing that need to be included. Next slide, please. In order to corral this entire book into something that was uniform for each author, we came up with a 7-point item that the authors had to write around. And so the contents of it were a description of what the distress may be, the severity of that distress, what tests needed to be done, the identification of the causes, and then the big one, the evaluation of what that distress was, what caused it, how to prevent it, and so on. And then the last section was the treatment and repairs, and then references. Next slide, please. You're going to see some of these slides throughout, but I wanted to point out something to this group, and that is we had to come up with a way to make people understand what that distress was. And so the committee felt that a lot of pictures, a lot of images of distresses should be shown, and as large as they could be in an affordable manner. Obviously, it went up to 470 pages. A lot of it had to do with the fact that the photos or the images were pretty good size. Next slide. We also came out with a lot of graphics, displays, drawings, if you will, trying to explain some of the distresses and how to prevent them and some of the repairs, as you can see on this slide. Next slide. And then finally, the one that probably made as much big of a difference as even the photos and the sketches was the tables that we came up with. A typical table, as you see in front of you here, has the distresses identified, and then over across the top, as you move to the right, are the causes, and then the preventions through design, material selections, construction, and maintenance. So when you get into these particular chapters, you should have a pretty good array of not only the images and the sketches, but also a table explaining everything, along with, just as important, was the dialogue. Next slide, please. In order to give you a very quick rundown in the next 45 minutes, I'm going to explain each chapter very quickly, so we can get through everything in a very quick manner. And I apologize for that, but you can look at the book online. By the way, the book is online. The guide is online. You can get it along with the EPUBs, which I'll show you at the end. All right, the first chapter, beyond the introduction, is the surface defects, which covered map cracking, plastic shrinkage cracks, scaling, surface polishing and wear, and pop-outs and mortars, based off of some of the issues of high water cement ratios, high amount of cement, low abrasion resistance, chemical de-icers, and overworking the surface, and poor curing practices. Next slide. The third chapter was surface delamination. This was kind of hard to get our hands around. We went out in the field a lot on this one. And really, it covers the differential consolidation, overworking the surface, inadequate or late curing, compression shears, as pavement moves together at joints, particularly the transverse joints, and then horizontal plane of weakness that is created. Next slide. Chapter 4 deals with our material-related cracks, the decracking, the ASR, and the ACR. Next slide. Chapter 5 goes through the transverse and diagonal cracking. This is a pretty good sized chapter. This chapter, along with chapter 6 and 7, are pretty good size. It goes over the temperature, humidity, and joint, particularly the lockup, improper joint spacings, the timing, and the sawing of the saw and the depth of the saw, transverse loading, mixed proportion and shrinkage, and then, of course, the foundation support. Next slide. Longitudinal cracking, which we will, at the end of this near the end of this presentation, I will go through one chapter, and it'll be longitudinal cracking about some of the details of the chapters. This had to do with the subgrade support, base erodibility, some sympathy cracks, late sawing, excessive panel widths, which I personally see is probably one of the biggest problems we have, along with late sawing. Traffic loading, poor joint layouts. When we overtie our shoulders that have some vertical movement, and we've had a lot of issues with that in Iowa on our overlays, for example. Next slide. Corner cracking, which we see a lot of, unfortunately, but it's true. We do see some heavy loading in the wheel paths and corner slabs when we don't have a proper load transfer and edge support, particularly edge support. Loss of foundation support due to pumping, volume changes of the subgrade, and then the poor, and that's jointing, not joining practices. Next slide. This chapter is probably the biggest chapter, chapter 8, has to do with the joint spalling, which in the particular state I live in is probably one of the larger city issues that we face with because of pretty poor air entrainment issues that we faced. Has to do with the infiltration of incompressibles, freeze-thaw damage to the paste, the saturation of the joint, compression shears that goes into the compression, and then poor soundness of the aggregate and the durability of the aggregate. That plays a bigger role than most people think. Next slide. Faulting, loss of the load transfer, failure of the aggregate interlock, or any help with the load transfer. Water intrusion under the joint, and then the injection of the water and soil beneath the joint. Next slide. Curling and warping, we're learning a lot about that through the years, have for the last 5 or 6 years, I would say a great deal about it. It has to do with the temperature gradient changes during the day, typically associated with the curling, high coefficient of thermal expansion, and then the dry shrinkage and moisture characteristics resulting in some of the warping issues. Next slide. Chapter 11 is blow-ups. We typically see those when we see heat wave, so along with association with entrapped water, and sometimes with the high coefficient of thermal expansion and poor pavement drainage, which leads to that. Next slide. Chapter 12 was the subgrade support, subgrade and base support conditions. We started calling that settlement in heaves, but it confused people, so we changed it to subgrade and base support. Primarily what we're trying to talk about is some of the settlement issues. We don't have too many heaves, but we do have some. But settlement. Soil is prone to volume changes as a function of moisture and density, poor drainage of the subgrade, contamination of the base layer, and then inadequate compaction and non-uniform soils. Next slide. And then chapter 13, which is our last chapter on full depth pavement, which was a continuous reinforced concrete pavement. Some of the issues that you'd get into associated with the poor base materials, insufficient longitudinal steel, variable strength, high level of friction, ineffective depth of the cover of the steel, and then poor consolidation around the embedded steel. Next slide. That took us through all the full depth pavement distresses and solutions. And I want to emphasize something. I know it bothers some people when we talk about distresses in our concrete pavement, but they do exist at times, and now we have a document that can address them. I don't want to overemphasize that our pavements have a lot of distresses, but we also have some loose solutions. But when we do have them, we need to address them and deal with them. So this chapter, this division is division 2, and chapter 14 goes through the concrete overlays chapter on the distresses, causes, prevention, and treatment. Next slide. On chapter 15, we go through the bonded overlays, which is on asphalt, the bonded overlays on concrete, the unbonded overlays on asphalt and composites, and the unbonded overlays on concrete. Next slide. This one is kind of interesting because this section's because we see a lot of it in our Midwestern states in regards to concrete overlays. So if we see any distresses, typically are more in the cold weather areas. Not necessarily all, but some, the majority. And we talk about the interior unbonded interior structures and other lanes. I think this first upper left-hand photo, Matt, came from Julie Vandenbush out of some of the testing that she had done. Shows the wheel line fractures that you get when you have an inadequate overlay, typically in a number of reasons, but one being thickness. The next slide over, which is to the right, is the longitudinal lane shoulder spalding. That's when the shoulder starts coming up. And in some of our cold weather states, water will get into a poorly drained shoulder and lift. In this particular case, that's what's happened. And when you have tie bars into a concrete shoulder, that can cause longitudinal cracking because the shoulder lifts and the tie is there, and so the crack will typically occur right at the end of the tie bar, particularly when you have a heavy loaded corn wagon or agricultural wagon come down the shoulder and pop it back. You have compressive joint, sometimes issues that's associated with movement, a lack of opening of the joints. In this one, it happens to be on a county road that the joints were not opening every 6 feet, and what happened is that after about 4 or 5 of those, it started to move the only joint that did open. You can see down in the lower left-hand corner some transverse joint folding. I know Tom Perham has been interested in that. We've seen some panel migration, and slippage with bonded overlays over asphalt, and some longitudinal wheel cracking in the wheel path. Next slide. Bonded concrete over a concrete. We don't see an awful lot of that bonded in concrete as much as maybe we did some 10 years ago. Not necessarily because it's not a good product. It is a good product, but you need contractors got some experience, some engineers that know what they're dealing with. So you'll see a little bit less on the BCOC, bonded concrete over concrete. You see some reflective cracking, obviously, because it's bonded to the concrete. And as you move to the right, the multi-panel cracks near the panels end due to some debonding longitudinal cracking due to fatigue after debonding, late sawing, which we all face with all kinds of pavements, wheel path cracking, mainly that's fatigue cracking, and then reflective cracks, not cutting the joint over the existing cracks, it's not lining the joints up. Next slide. Unbonded overlays over asphalt, we're seeing an awful lot of that throughout the country. We do a lot of technical assistance to states. We'll be heading out to California to be working on a large concrete overlay project out there for to help them on one of their large projects on an unbonded overlay over asphalt. Sometimes you'll see the longitudinal cracks in wheel path with tied and widened shoulders. Also, you'll see some faulting at the panel due to the deformation of the underlying asphalt as we move to the right at the top of the row. Diagonal cracking, diagonal longitudinal cracking over the widened sections we've seen. And I should have mentioned something earlier, way when we first started, and I apologize for this. Typically, in the distresses that you see, any cracking or faulting or movement of the pavement normally is associated with more than one item, more than one cause, if you will. That made the book very difficult to write because you were faced with trying to not repeat yourself, but you were forced to do so because sometimes there's more than two, even three reasons why, even sometimes more reasons why you may have some distresses show up. Cracking in the lower left-hand corner is a misalignment of the dowels. Mid-panel cracking primarily is some lack of support from beneath the pavement. And then the blow-ups, as we talked about earlier, pretty much common with it's the same, not common, but the same issues associated with full-depth pavements. Next slide. Unbonded concrete over concrete. This is the last slide under the distresses that you'll see today. I'm doing a little bit better than I thought in timing. You'll see the longitudinal cracking the wheel paths with tied shoulders. Again, that's mounted on concrete. Again, that is sometimes the movement of the shoulders. Mid-panel transverse joint faulting. Sometimes we do use a inner layer that's asphalt, 1 inch of asphalt, not the geotextile inner layer. In this particular case, I believe this came from Minnesota, but I'm not positive. You'll see some loss of load transfer across that joint. And then the next one over to the far right, upper right, is the longitudinal cracking in the wheel path. Again, from the same issues that we face with a lot of other types of pavements, be it unbonded or be it overlays or full depth pavements. Transverse reflective cracking, how could that happen? Well, it does happen sometimes when you have a loss of stripping of if you have a loss of asphalt, some stripping, or you have a large crack underneath your pavement into the existing concrete, and you have sometimes an asphalt interlayer. Mid-panel cracking, again some stripping of the interlayer, and then the cracking due to the misalignment of the dowels, which we've all faced sometimes. Okay, next slide. This is Division 3, Chapter 19. And it has to do with some of the common field and laboratory testing associated with the pavement distresses that I just talked about. Next slide. The common field tests, as you can see in front of you, and I'm not going to run through all of these because they're pretty well known, goes from the chain drag all the way to the high-speed ground penetrating radar, the GPR. I think the one that's getting more attention, actually two, I would say. You know, FDR has been around quite a while and we've been using it quite effectively. But the automated plate loaded test, and there's some specialists out there now. In fact, I think there's one of the larger ones. It's in Minnesota, using the plate loaded test. It's pretty unique testing device. Then the more simple one, which I've been encouraging even our city engineers to purchase, because they're only about $1,200, is a dynamic cone penetrometer. Gives us an awful lot of good information, and we've used that considerably. Next slide. The common laboratory tests for some of the subgrade and base materials are known. There's nothing new here for you other than the fact that it takes some young engineers or inexperienced engineers a reminder of some of these laboratory testing that they can do. Next slide, please. And then the common laboratory test for hardened concrete materials, not as well known throughout the country because a lot of them are in, obviously they're in our laboratories, and they're not run by us so much as they're run by specialists, but we get the results. One of the big ones, of course, is the petrographic examination of the concrete, be it aggregates, be it the paste, whatever it may be. Excuse me, I missed the top one. The compressive strength test we know about, the flexural tests we know about, hardened air petrographic analysis. We probably heard more about it, but this is examination, the picture of one of the examinations, along with the aggregates for petrographic analysis. I think one of the ones that intrigues me the most is the surface resistivity test. The rapid chloride test that's been used for years has some larger than what we'd like to see variations in the results, and the surface resistivity test is becoming more and more useful because it doesn't have the variation, as much variation. And then the last one on this slide is the resistance of concrete to freeze-thaw damage, which we're quite familiar with, I'm sure. Some of the tests are not in here, everybody. I can't get them all in and do it within the matter that I'm given, the time given. So you won't see all the slides on all the laboratory tests or all the images and the descriptions in this presentation. Next slide, please. Okay, here's the one I want to run through for the next 10 minutes or so. And that is, let's take a look at a longitudinal cracking chapter, and let me kind of explain the steps that we go through. And it's a pretty typical chapter. The first slide that you see here is, well, the longitudinal chapter is 37 pages. When we first started out, I told the authors and myself, who was an author on one and partial on two other ones, that I didn't want the pages per chapter to exceed 15, maximum 20. Obviously, I missed that quite a bit because once we got into it, it was like eating chocolate or peanuts. When you start, you couldn't stop. You had to get it through. This first slide shows a picture of a longitudinal crack, and you can see some of discoloration in the crack itself and a little bit of vertical movement. When you see those two, you probably know more than anything else is that you've got some support issues below the pavement. Next slide. Longitudinal cracking along the joint line, probably late sawing, I would guess. Our saw cut is not deep enough. These first few slides that you see here are in every, the array of slides are in every chapter. The first page or two are just slides with some descriptions in it to give them an understanding of what is going to be covered in the manual or a guide. Next slide. Then we go into the severity. What is that severity? Now, we tried to utilize the FHWA severity information, but it didn't always fit, particularly in overlays. But if we could, we use the low, the medium, and high severity and utilize what FHWA had published in the recent publications. And this is an example of that. Next slide. The third thing we looked at in the manual or in the guide for each chapter was the field testing and then the laboratory testing. Here you can see some of the field testing that was identified and some of the laboratory testing for the temperature and shrinkage characteristics that we listed out. Now these are just points, the descriptions, the dialogue goes with all of this in the real guide. Next slide. And then we would look at, right off the bat, because we wanted people to understand some of the distresses on every chapter, this one being longitudinal, and what category did it fit in? Did it fit into a physical category? Did it fit into a material chemical category? And so we identified the causes. Before we get into the evaluation, we want to identify the causes and then give them a quick summary table along with dialogue when they want to delve into it a little bit more. Next slide, please. Item number 5 in this chapter is the majority of the work. It consists of 25 pages out of 37, and it talks about the causes, and then right after the causes, it talks about the prevention. And it goes through, in this particular one, 4 or 5 major items. The first one would be excessive slab widths. What causes some of those issues as associated with not only the dimensional side of it, but on the physical side of it, such as the base stiffness, what affects those. Sometimes you can get by with 14-foot or 15-foot or 16-foot wide slabs on some type of pavements, concrete pavements, and other ones you can't even get by with 14-foot, and they'll crack in the wheel line based off of many factors, and some of them are listed here for your information. Next slide. Late sawing or inadequate saw cut depths had, of course, to do with the timing. I have to pause here for a minute, everybody. I preach to people to turn off their phone, and I didn't do it. I apologize. This is late sawing or inadequate saw depths. It has to do with the mix, the timing, the mix parameters, the pavement and base, and the curing conditions. Primarily, it's just plain missing the depth and the sawing time window. Next slide. Non-uniform support. The non-uniform support was resulting from some of the inadequate compaction, erodibility. Subgrade volume stability is pretty darn important, and it needs to be looked at. In too many of our cities and our counties don't really treat their soils on a uniform basis, so you have differential soils which reacts differently to the water and to the temperatures. So you get vertical movements. Next slide. And now you see some of the tables that we get into in regards to the evaluation. Foundation in this particular case is the subject matter as it goes through the aspects of it and some of the issues and some of the considerations to be given in order to get that uniform material. Next slide. The evaluation also included these other ones. I didn't go into those details because we're going to be running out of time here, so I want to make sure that you did understand that we did go through traffic loading and some of their sub task, cracking at intersections, sympathy cracks, over reinforcing of tight joints, and then tying new lanes to existing lanes. Next slide. And then this is typically the largest charts for each chapter, and that's the evaluation summary of causes and preventions. And it goes through the distress in the concrete pavement on the left-hand side, and then the contributing causes, and then it goes through the design, materials, and construction prevention for each one of the items. Pretty handy charts. Next slide. Treatment repairs. We have so many manuals out on repairs for longitudinal cracking, on repairs for transverse cracking. But the committee felt pretty strongly that we needed to have a section that either referred us to those particular documents that I referred to, or give a overview of what those are. Our treatment repairs does not go into a lot of detail. It goes into sections where you can get an idea, and then we make references to other documents that can cover the subject matter in more detail. Some of the ones that we did include were on the full depth repairs for longitudinal cracking, the cross stitching, mainly because you don't see that often. The crack sealing, of course you do. Slot stitching, you don't see that often, but we did put it in the manual. Diamond grinding and filling. Next slide. Okay. I did that in about 45 minutes, which is my goal, to give you time to ask me questions if you have any. You can find the guide, the stress guide, at the CP Tech Center website. You just go to the publication side and you'll find it. It also has the EPUBs document on it, and you can find that on the same website. I would tell you that you will have to have a app to open the your EPUBs document on your phone. I've got it on my phone. It works great. I've got it on my computer. It works great. I personally prefer the book, but that's because of my age. If there's any questions, then Robert, I'm more than willing to answer them. And thank you for the opportunity to give you this overview of the distress guide.
In this room here, is there any questions for Dale? Bernard, I think that everyone can hear you, so go ahead and speak loud.
Hello, Dale. This is Bernard. My question has two parts.
I'm sorry, Bernard, I can't hear you. I
Walk up
apologize.
here, Bernard.
Where's the microphone?
The microphone's in the room, so Bernard just has to speak up.
Okay.
He says
Dale,
quiet.
can you hear me now?
Yes, I can hear you now.
Yeah, I said my question is in two parts.
Okay?
At A, do you or did this manual address the fact that, you know, more frequently these days we are dealing with thinner pavements, and distresses could have probably been addressed in those days with a partial depth repair will suddenly become a full depth repair. So was cognizance taken of the fact that pavements are thinning out, and therefore it would affect your mitigation, the kind of distresses you should find? And secondly,
I apologize, Bernard. You're going too fast for me. I'm not catching your dialogue. Sorry. I'm sorry. It's my fault.
okay. Let's take it again.
Okay.
Pavements are now thinner than before. Does the manual address the factors that are associated with the fact that we now have thinner pavements? For instance, certain things that would have been treated as partial depth repair, that would have defaulted to partial depth repairs previously, because of the thinness of the pavement, may now call for a full depth. I mean, does the manual inherently address the issue of, you know, mitigating the distresses in thinner pavements? Let's start with that one.
Help me out, Robert, because I heard part of it, but I didn't hear all of it.
Maybe I could translate a little bit. Bernard's saying that pavements are now being designed thinner. With that fact, there are some of the fixes and things like that that are shown through the guide, like partial depth repairs. Is that now full depth repairs, or how did the panel kind of look at, quote, thinner pavements of today versus before they're all kind of thicker?
Well, primarily partial depth repairs and full depth repairs. Obviously, we put them both in there. As far as of addressing what the thinner pavements are all today, is we really didn't distinguish what today was versus 10, 15 years ago in regards to the thickness. We addressed the thickness that we were faced with, because we're seeing pavements that are out there that are just starting to show distresses 45 years ago, and I'm not exaggerating, because they had a very good air system and a very good base system and a lot of other good systems, but they were relatively thin. Some of them were 8 inches or 7 inches. Today, we'll see that same pavement with a good air system that may be the same thickness, but it has a lot of different properties. So rather than the thickness, we try to deal with the properties that we have both in the past, 25, 30 years ago, and in the properties that we are faced today, because sometimes, unfortunately, we do have some early distresses in some of our new pavements. So to answer your question, Bernard, I feel that we didn't really address the thickness of the pavement as we tried to address the items that are in the pavements, the fly ash and some of the base material that we use today versus what we used years and years ago. I hope that answered some of your question.
Like 30% of it. But let's go to this. Let's go to the second one. Can you hear me now?
I can hear you now. Talk slower because I'm old and I can't grasp it as quick.
All right. We now use the non-woven fabric as interlayer. That's gradually replacing the PAS rack, the permeable asphalt stabilized stress relief layer of those days. And then what we have observed is that there is less propensity for spontaneous deployment of the joints. Even though people are now doing things to activate joint deployment when we use the non-woven fabric as interlayer, are you seeing any unique distresses that are associated with the use of the non-woven fabric as interlayer, as stress relief layer?
Robert, help me out a little bit. I think I've got it, but I want to make sure before I answer.
With the fabric layers that are being used for overlays,
Right.
are you seeing any new types of distresses because of that?
No, actually, very little distresses. I'll tell you where we did see some. In Little Mac in Michigan, and we don't see a lot of that on that roadway. It was just unique. The fabric that we saw distresses with primarily were with too thick of a fabric. And that's kind of hard to believe because we're talking about millimeters. But this fabric in Little Mac in certain areas were thick enough that the joints were moving up and down and actually causing a noise, if you will, in the joints. And so we drove down the street. I didn't, but Gary Fick, at my request, did, and so did Rod Rasmussen. And they drove over it. You could hear the joints grinding because they were dropping. Now, that left after about 2 weeks, but that issue did not leave in certain sections, particularly when a driveway, a commercial driveway, was tied into the edge of the overlay, not tied per se, but had aggregate interlock, full depth driveway in a thinner unbonded overlay on top of fabric. And the result is that the aggregate interlock between the driveway and the edge of the overlay was significant enough that when the trucks came down on top of the concrete overlay, it moved. It moved enough that it cracked the overlay because the one portion of it was held in place very well with the aggregate lock, and the other portion of it, when it got onto the fabric, a couple of feet, it cracked it. That's the only time I've seen issues with the fabric associated because of the fabric. I hope that answered your question.
All right, Bernard gets no more questions. Are there any questions online if you type them in? I had a question, Ben Worrell here. With the use of fibers these days, did the manual talk about fiber issues, anything like that?
Not as much as maybe I would have liked we had, but no, we did not. The issues associated with fibers, we're probably getting, remember, we started this about 3 years ago. We chose that chapter and started writing. So 3 years ago, fibers, although it was being used in some portions of overlays, it wasn't used predominantly. Now today, for the last 2 to 3 years, I would say, we've used a lot of fibers. You caught something that I wish you hadn't brought up, because it makes me ill inside to think about the fact we didn't do the fibers as much as maybe we should have in the manual. But to answer your questions, no, we didn't deal with it a great deal in the overlays.
I mean, that kind of makes sense to me because it's pretty new. I mean, there's been fibers for a number of years, but not widely used, especially in pavements, maybe more in industrial slabs and things like that. The other thing, with white topping, Tom Burnham always talks about the faulting and white topping.
Yep.
Does the manual talk about that?
Yes, it does, because he was on the committee and he wouldn't have let us got by without it.
I want you in on a positive note. Is there any other questions?
Great job helping us.
Dale, nice job. I think all of us should take a look at that manual and really see what positives it can provide us for our engineering use. So thank you for your time. Really appreciate it. Bob, what is our next Research Pays Off? I've forgotten.
I think Manic, Forrest Eaton from Iowa State University again is going to be talking about determining pavement design criteria for large stone sub-base materials.
Okay, so we'll kind of go into the geotech world next month. So again, if you have ideas for a future Research Pays Off, please let any of us know, and we'll let Bob know. I guess we do have one question here. Take a look at it real quick.
Whether penetrating sealers are cost effective.
Did it address that in the guide? Not really, because we don't have a lot of good answers on it yet. We're starting to get some. We've got a number of test sections out there, and as I understand, Minnesota's got some. We have a number of them in use today, but as far as penetrating sealers having a point of repair or a point of prevention, not really, because we really don't have the answers we were hoping for by this time. We think we will have in the next couple of years. Did that answer your question?
Yeah, kind of same as fibers, I imagine.
Yeah. Look at everybody. It's amazing how things can turn around in 3 to 4 years. It really is. And fibers and sealers are two of the biggies that are out there. Would it be acceptable, Robert, for me to ask, well, I guess I'll just ask anyway. Maybe you don't want me to, but I will. I want to see Matt Zeller, who was on the committee, and Tom Burnham to make any comments about the process we went through or the things that they felt they want to contribute to the discussion here.
This is Tom Burnham. No comments. I mean, I think it's a very good way you did it, where you had the 16-panel technical. You're asking the experts around the country. So this is the best state-of-the-art information that we have at the time, and at least our opinions on it. So it's a greatest step way over the basic LTPP distress manual, because you're getting into reasons and causes and the timing is very good. We're in Minnesota, we're going after these knowledge books. There's a lot of people retiring, so just the timing of getting, picking people's brains before they retire, I think, this is another resource demonstrating this effect that we need to get the word out there.
Thank you.
Dale, I don't see Matt on the line right now, so
Okay.
unless he's using another name these days.
Well, I appreciate the 31 participants. I apologize very much for not having the screen as large as I could have had it. I'm sorry about that, Bob. I don't know what happened, but it certainly did. So, but thank you for the opportunity, and I really, really appreciate it.
Thank you.